The latest research trends envisage the collaboration between human operators and industrial robots. The European project Robopartner aims to define strategies for removing fences, and allowing human operators and industrial robots not only to work more closely but also safely. The focus is given to providing efficient means of supporting the human operators, under a safe collaboration scheme, by integrating for the first time, technologies such as augmented reality, smartwatches and voice commands. Smartwatches have become popular over the last years. Thanks to their ease of use, LMS has developed applications that allow the pairing of a smartwatch with the operator's glasses, by means of a simple QR code scan. A pilot case from the automotive industry, involving the assembly of the rear-wheel group, provides an ideal scenario for the workout and validation of the Robopartner concepts. To guarantee the operator's safety, LMS in cooperation with Pils and Comau, have designed safety concepts, using state-of-the-art sensing and control technology. The Pils Safety Eye sensor has been integrated for the first time, directly with the robot motion control, enabling the dynamic changing of safety zones. Safely monitored interference regions, provided by the Comau C5G control technology, are also used in order to ensure in a certified way that the robot tool is always in the desired position. In this way, the human operator can easily and safely move and work closer to the robot. In the Robopartner, the role of robots is to undertake physically demanding tasks and act as assistants to humans. In this case, a 14-kilogram wheel group is carried by the robot from the kitting to the assembly area, so relieving the operator of the strenuous task that has to be repeated more than 500 times within a shift. Physical strength, gender and age barriers will no longer be a constraint, thanks to the human-robot synergy effect. The vision is to exploit the robot's power, accuracy and repeatability with the human's intelligence and dexterity. In the final application, the same robot will be used in order to load the complete axle, and further reduce the non-value-adding tasks that are now performed by humans. Through the use of the augmented reality technology, Robopartner aims to reduce the cognitive load from the operators in the factories of the future. An innovative smartwatch interface allows the operator to receive assembly instructions and intuitive visualizations for every task that needs to be performed. The request for support is transferred through the smartwatch to the augmented reality glasses that can overlay 3D models and text-based information on the operator's field of view. The communication loop between the human and the robot is closed through the capability provided in order to confirm the task's completion, with the pressing of a button on the smartwatch. To coordinate the common workflow, LMS in cooperation with Intersoft have implemented a service-oriented integration platform, based on ROS. The platform acts as the central execution controller, monitoring and visualizing in a web interface the production status, based on the feedback received by the robot and the human. To further increase the awareness of the operator on the execution status, visual alerts are provided through the augmented reality interface for events, such as the robot motion start and stop. The integration platform ensures at all times that all tasks should be executed in the correct order. A closer collaboration between the human and the robot is achieved when they operate not only in the same area, but also on the same product. In this scenario, the robot is holding the heavy part, and at the same time, it allows the operator to manually guide it to the proper assembly position. The robot supplies the required power, and the human contributes the perception and intelligence functions required for alignment and assembly of the parts. Throughout the collaborative operation, several underlying safety concepts are applied. To avoid collision of the robot with the environment, virtual volumes are used in order to constrain its tool in the 3D space. The operator is able to visualize these regions through the augmented reality glasses, and thus be aware of the high-risk areas that he or she should avoid when guiding the robot. As a last resort, the robot will not allow movement outside the defined areas, so as to guarantee safety of all production entities. Further approaches to simplify the interaction between the human and the robot involve the use of simple voice commands. Through the developed smartwatch interface, the operator can verbally request the robot to stop or resume its operation. Moreover, primitive movements can also be performed in order for the robot to be guided to the desired position. The smartwatch acts as an enabling device, allowing the robot to move only when the operator's finger is in contact with the screen.